Okay, I'd like to get this started since we've got a pretty hard deadline at the end to finish up so we can have the social program. This is the session on future gravitational wave detectors. We've got 5 panelists. They'll each be talking for 17 minutes plus 3 minutes of questions, and that would, if everything works well, will leave us about 15 minutes now at the end for discussion. So I'd like to start by calling on Jo van den Brand to tell us about the situation for future gravitational wave detectors in Europe.
Okay, thanks, Stan. So, Bala, I hope you're enjoying this as much as I'm doing. I would like to thank the organizers for giving me the opportunity to speak. So I will talk about 3G opportunities in Europe. So I'm from the Virgo collaboration. So that is about 400 people from 80 institutes in Europe, and then centered around the Virgo detector in Italy. We managed to join the last 3.5 weeks of O2. And so in total there were about 13 months of observations before that. I remember that in May 2017, our sensitivity was 30 kiloparsec, and that we got a factor of 1,000 in 3 months time, so we just barely made it. When we joined, we only knew about 2 detections, so I was not very optimistic at that point. I actually went on vacation. But this was a good month, so these are all the events in O1 and O2. And Virgo had some contribution to these 5 here. So mostly in pointing, so Virgo helps in pointing, and somewhat to parameter estimation. So right now there is a global network of LIGO and Virgo, and you also see that by adding to the global network that you gain things that you couldn't do before. For example, measurement, getting access to polarizations of gravitational waves, getting better pointing was something that we brought to the collaboration right now. We hope that Kaga will join this year, and of course we're looking forward to LIGO India in 2024. And then this global network will be the basis then to go towards third generation. Because at the end, there are always the same people doing these things. So let's think about it in a global fashion. For Virgo, the fact that we could join had quite an impact. So many new groups strengthened the collaboration. So in 2018 and 19, you see groups from Spain, Belgium, the Netherlands, etc., and many that we are talking to that also want to join. And the reason that they are joining is that, first of all, they're intellectually excited by the things that we are doing. But then the reason to pick Virgo has to do that they also see it as a stop towards third generation, towards Einstein telescope. And I think it's good for everybody because this is additional resources that we can use in our collaboration. So April 1st this year, we started observation run 3. You can see that many people are happy by that. We had a goal that is given here by this shaded band. And we didn't really reach that. We still have some deviation over here. So we got around 48 megaparsec instead of the minimum of 60 that we're aiming at. We're still trying to figure out what to do there. Maybe it can be fixed in the October stop. Nevertheless, what we are doing is we're looking at the future because all the interferometers are, the sensitivity is essentially limiting the amount of science that you can do. So what we would like to do is upgrade, and in parallel with the A+ upgrade in LIGO, there is also the Advanced Virgo Plus upgrade that is recently approved, and we're working on that right now. So we need to do this in order to keep the scientific relevance for Virgo, and also to safeguard all the investments that were done. But you want to take it a step further. So thinking about third generation, we also would like to try some new technologies, some innovative things that also then de-risk what we want to do for third generation. And I think this strategy is one of the reasons to attract these new groups to the effort. So the problem that we are in is that we have all this science that we were talking about, that there's this big community that is looking at results coming out of LIGO and Vrbo and that want to do science. But at the same time, we know that if we double if we improve the sensitivity, we rapidly increase in the science that we can produce. So this has to be carefully managed. So we will run till the end of April, then do a first phase of the upgrade, run 4, and then do a second phase of the upgrade. Essentially, what we are thinking about doing is first reach the thermal noise, so set by the thermal noise on the coatings and on the suspensions, and that is increasing laser power, signal recycling, squeezing, etc. And then we would like to shift this thermal noise wall down. And the idea there is to start putting in bigger test masses, so about more than 100 kilograms, having new coatings. And these are, of course, fantastic objects if you think about these test masses. If you would magnify one of the test masses to the size of Bangalore, then the surface variation is less than the width of human hair. And then we put all kinds of coatings on that. So these are very exquisite objects. So that's what we're trying to do. If you want to do that and you want to be ready, so before the start of 04, then you need to produce mirrors, you need to select materials, you need to get all your coatings in place, your polishing of substrates, etc. So there is no free time here. So we are again under time pressure to do this upgrade. Every time that you think about doing a major upgrade, I think there should be new science that you would like to deliver. And so I think what will become a reality with A+ and Advanced Plus are these things that you often have seen. I think with getting these events on a daily basis, we should be able to say something about the Hubble parameter. And I think we should be able to say something more about the equation of state. And I think that already, to me, makes it worthwhile to do these kind of upgrades. So that is fine, but people are also talking about third generation. So what is so dramatic about third generation that you want to spend billions doing this? So one of the things, if you think about the Einstein telescope, we would like to have very good sensitivity at low frequencies. So that means that starting from, let's say, 2 Hertz, we would like to get these signals in band. And that means that all the things that were discussed about precession effects, etc. So, and I guess everybody understands how crucial it is to determine spin, what you can learn once you have the spin degrees of freedom. I think that is something that we should be able to measure. Another thing is that we will get hundreds of events per day. So you cannot follow everything up, but what you can do is start doing already preliminary analysis and trying to pick out the most interesting ones. And since you have hours early warning in advance, you can try to make statements about what are the interesting events and alert the astronomers to put their telescopes on the interesting ones. Another thing that you have seen often is this plot here with the post-Newtonian parameters. So with, in a few years, a data set of 100,000 events, in their events with signal over noise of, let's say, 800 or maybe even more, the precision that you will get on these parameters will be at the per mil level. So we understand that right now, even the waveforms, whether this whole, the way the higher order terms are neglected right now in this expansion, I think there's a lot of work for theory if you want to take advantage of the science that is going to be produced here. And then there are other endeavors like LSST, SK, Theseus, where also big data sets over the entire universe are produced. And there must be quite some interesting information in the cross-correlation of these different data sets. And then hopefully some surprises. So this, I think, are the usual things that you think of, and you think of them because that is what we are doing more or less right now. We are starting with that. But what motivates me more is the discovery potential that you would have if you would have to have a device like Einstein Telescope. So right now we're looking in the local universe, and now with Einstein Telescope you can start looking in, let's say, the dark ages, so before star formation. Then you can say, okay, so why do you do that? There's nothing to see. Or that is debatable whether there is nothing to see. At least you have the real opportunity to get direct access to this epoch over here. You could have more surprises like primordial black holes, maybe signals from the universe, and axions that were discussed that you might see in the modulation of these populations. If you plot, for example, spin versus mass of the black holes. And if you take different models, then you also see that you see that there might be quite some black hole activity in this early universe that you could directly access with 3G instruments. So if you want to do this in an optimal way, you would like to have excellent low sensitivity. So that is the reason that we're thinking to put it underground. You see then this here, you would get redshifts up to 100 and quite some access to the mass range of these black hole systems. But at the same time, if you want to do all of that, we are changing so many things. We are changing the materials of the mirrors. We want to change the coatings. We want to do things cryogenic. We want to change the frequency of the lasers. So all of that requires heavy R&D. You will hear more about it. So I think the good news is that funding is becoming available. So this is a new R&D facility that has been funded and that will be built up. And we're looking forward to collaborate with everybody worldwide on this type of R&D. The other thing is that, of course, you can use this also as a good training facility for younger people. That is important since I think Virgo right now is not a training facility anymore. So I think it's good to have these kind of devices. The other thing that by starting with these kind of activities is that you see that apart from the money, more important is that all these new groups are expressing interest in gravitational waves. And many of them are right now seeking a membership of Virgo. The same is happening in Italy, because that is another candidate site for Einstein Telescope. You see also that at the government level, funding is earmarked to do both R&D, but also to upgrade Virgo. And that is part of the same strategy. Actually working on third generation, doing part of the R&D on that, is to some extent also part of the Virgo activities. So let me summarize. I think there is a great interest in our science. I think you see that we are still growing and attracting good and strong groups. Many, typically in Europe, from high energy physics. So for some reason, they are attracted to the fundamental physics aspects of it, how the details of gravity can be tested, and also the cosmology. And to a lesser extent, the people that are working on LS and heavy ion collisions are attracted by the equation of state science. So resources are being committed right now to the upgrades. So that is the next step that we need to take. And of course, it makes no sense to talk about third generation if you don't get optimal performance out of the current instruments. And the funding agencies are very aware of that. So we need to upgrade and get good performance in Virgo. Another thing that worries me is that I think we should make an effort to make a global community out of that. I think globally we want to go in this direction. And we should not think about separate experiments. So I don't know exactly how to do that, but there is something starting already to come to a global community on this. And for us, the next step that we need to take for Einstein Telescope is to get this proposal written and get it on the European roadmap. So if you get it on the European roadmap, it doesn't mean you get money. You get a period of 10 years where you can try, you will get support to realize this project. So the window for that is next year. If we would miss that window, the next window is 2024. So that is what I wanted to share with you. Thanks.
Thank you very much, Jo. We have a little bit of time for some questions. You
That's amazing.
made it great. So we have.
I was just wondering, I mean, this might be a naive question, but are there efforts to get funding from non-government agencies, like private agencies, to push it forward, or is that completely out of the question?
No, for our activity, there are no private parties that are putting in significant resources. What you see is that regions are putting in resources. And for example, one of the Einstein telescope site is on the border region with Germany, Belgium, and the Netherlands. And that gives possibilities for collaboration. So you might hear in the news all the conflicts within Europe, but there is also lots of programs that are trying to foster collaboration of these regions. So that R&D project was funded through that, didn't come from the Dutch science funds. And the same is true for the activity in Italy. So it was also more regional funding. Then there are companies that are excited by that for obvious reasons, and they collaborate. So they put in resources, but of course they have an agenda to do that.
You mentioned about the need to complete the ongoing detectors and achieve the sensitivity goals and so on. Are you suggesting that in order to apply for funding, you already require to have achieved the sensitivity goals that are promised, or is it just that this is a wish list of achieving sensitivities, but we should start the 3G program? Because it's a long, I mean, if you wait until you achieve sensitivities, then you can only run for 2 or 3 years, let's say. But to build a next generation detector, you require 10 years. So there seems to be some conflict in the timing of these.
I don't think there's a conflict. The fact that we have, so this is a strategy that we have. So we have Virgo right now. You go together, you try to get better sensitivity, you go into advanced Virgo Plus, and then you go into 3G. So that strategy is very clear. It also makes that new groups know what the point on the horizon is. And also for the funding agencies, they see new groups coming in and also taking care of the previous investments. So I think all of that works. There is no such thing as you first need to achieve this before we will give you that money. I don't exclude that this will come, so that if they're smart, they might do that.
All I know is that we need to somehow envisage the development of 3G detectors and have the data, not have a very long period in which there is no gravitational wave data available at all. That's the plan that we need.
Right, so I personally think it will take quite a long time. It is not so easy in Europe to get these things done in a fast way. So the best thing right now is get on the S3 roadmap, try to develop, try to see what the site is. But even at the same time, if you would not perform on Virgo, if you would not get these sensitivities that we promise, I don't think there's any chance we would build ET.
Shall I? Yeah, quickly. When do you envisage a decision between the Dutch and the Sardinia site could be taken?
Assuming that we will manage to get on the S3 roadmap, so that will be known in 2021, will be 2022, 23. I think it makes no sense to drag this out. I think right now to have these two possibilities is fine, but I think in 2022, 23 you need to decide if you want to make progress.
So for ET, for third generation ET specifically, we write data analysis papers assuming, in some cases, a 1 hertz lower bound. Should we stop doing that? You mentioned 2 hertz. Or would you rather us do that to motivate what we can do if we push?
I think right now this cutoff right now is somewhere between a 1 and 2 hertz. And if you look at the technical details, it has to do how some people think that you should do vibration isolation. And I could think that maybe after we listen to David's talk, that if you would do that in a smarter way, if you would take all the knowledge that is available on that, maybe you can achieve 1 hertz. I'm not certain. I certainly would not give up on that.
Okay, let's move on. Rana?